everyone. Happy New Year. How is New Year treating you so far? Treating me pretty well. Looking forward to a lot of things this year, and thanks for being here. It should be a lot of fun.
Yeah, totally. Hey, just to give a brief intro about me, I'm Ananth. I'm the author of Data Engineering Weekly. I've been following this whole development happening in the Lakehouse. 2024 is, I would say, the most happening in a way that it's a movie watching the way the Lakehouse development is going through this one. So I was talking to multiple people to understand what does that really mean. My day-to-day job that I have to really build a high-scale ecosystem for the companies. Apart from all those noises, what does that really means for us to build a data platform for an enterprise? I'm also curious about it. So I reached out to many people, understand what does that really mean in 2025 and futures, like where this is heading. And one of the conversations that I got into, and we had a long conversation. And then we thought, okay, this conversation should be really a public conversation rather than a private conversation. So even though it says dinner, it's really going to be a one-on-one conversation to understand where we are. So with that, thanks, Vinoth, for the time. I want to give a brief intro about you.
Yeah, thanks everyone for joining us today. And a quick intro, I'm Vinoth, founder, CEO at Onehouse, but also created Apache Hudi 8 years ago as the transactional data lake, as we originally called this technology category. It's today popularly known as the Lakehouse, as you all know. And I'm looking forward to this chat. Just to caveat all my opinions here, I'm speaking for me, I'm speaking for Onehouse, but not for the ASF or the Apache Hudi PMC in any way. The community has its own process that we follow to make any decisions. Like Ananth said, I've had great respect for what Ananth does. He's done this for 4+ years now, curating everything that's going on in the space weekly. It's not an easy job in a space as complex as ours. So I have great respect for Ananth. There's some of these very deep topics that we have. So I made some just purely visual aid. So we'll just show and tell as we go just to help the conversation along. But mostly we're going to keep this interactive back and forth. And look forward to all the questions.
Totally. Bit of housekeeping for the audience. Feel free to raise your questions in the Q&A section at any point of a time. We'll try to address that as the conversation goes, or towards the end, we'll try to group those questions and kind of answers. To begin with this, Apache Hudi is a pioneer in the Lakehouse industry. It came in 2017. It revolutionized many aspects of the industry, the concept of storing data in an object storage and having a database-like concepts. Just very interesting to me. When you started this project and when you're writing your first RFC, did you envision or did you have a thought like this will have a huge industry impact with this?
To be honest, no, but I had a strong feeling that why can't we do something like this? Mostly because of the previous 2 jobs I had. The 2 jobs I had before that was scaling key value storage at LinkedIn and dealt with LSM trees, B+ trees, log structured storage day in and day out. And before that, CDC storage, streams with Oracle and all of that. So when I looked at this problem, and we essentially had to integrate a lot of mutable data streams and high volume streams to a data lake. And then it felt we could borrow some of these database concepts and bring them to the lake. And that's how Hudi was really born. We actually weren't thinking about, for example, let's build a Hive replacement or anything like that. We wanted to solve these core hard technical problems that we had at that time at Uber and build a system that we can actually run. It was very controversial, to be honest, because at that point, Uber had more Hadoop committers and members than Facebook, right? And so everybody's, we didn't need this for 10 years. So why do you need this now? Why can't adopt a different data model to make the mutations go away and all of that? We did spend a bunch of time also not trying to build this. Right.
Mm-hmm.
But it basically got to a point where we are like, we have to do something about this. We actually had a business need to do this. That business need basically pushed us to build the project. For me, 2 years after, I kept feeling like this is the right technical way to go. The GDPR in 2019, 2020 is the thing that got this into mainstream. That is when you saw AWS announcing Hudi support everywhere. There's so much large installs of AWS even today, right on Hudi. And that to me was the single use case that everybody felt like, I cannot shove files into S3 and call it a lake anymore. I just need to have some kind of structured management around this thing. And from there, I think we have come a long way. And there is also like other projects who have contributed to the to this art, and it's just been a great ride. It's been 8 years. I didn't realize this. It's been 8 years since I wrote that first RFC.
One of the things I'm talking to multiple people about Apache Hudi and then other Lakehouse format like Icebergs and other things, right? One, like 2017, 2018 is where like this Lakehouse architecture came. I was at Slack at the time. We were trying to solve a similar problem. And we got this two problem set. I think like many people forgot that's the eventual consistency problem. Back then it was a huge problem. And we wrote like so many chunky codes on top of output format to overcome that. And by that, and then the high metastore scalability was a bigger problem also for the thing. We are also running through the same problem. And we got a preview of Iceberg before it was released. And when we saw the design, it was like, wow, really, that's really good. It's solving some of the problems that we are actually solving in the data warehouse side. And when we started to move to the CDC pipeline side of it, we wanted to bring in all the messages data from Slack. When we compare the design of Hudi and Iceberg, like Hudi much more fitted into a CDC pipeline model. My mental model was like Netflix, more of a data warehouse centric, understand their business, creating a new content or a studio kind of model versus Uber, more of a real time operational driven data science model. But I started talking to people. This is the number one point. Hudi is good for change data capture use cases or operational analytical use cases, but not really for a data warehouse kind of model.
Yeah, so the two problems that you mentioned are orthogonal and complementary problems, right? To answer this head on, not necessarily. This is a perception that people have because Hoodie's design and all of this is so uniquely, even today, like addresses how you can specifically applying CDC logs from databases to a Lakehouse table. Hoodie is really good at that. But it's also great for any batch ETL and uniquely so for any incremental jobs. So essentially, it's great for incremental writes to a Lakehouse table, right? And those writes, a lot of cases results from a CDC log, but you can write incremental pipelines and read your Lakehouse table and incrementally transform, write new tables as well. A lot of people do that. This is also why you probably hear people saying Hoodie is for streaming or things like that, right? So this is essentially Hoodie getting associated with the unique capability that it provides, but you can do batch operations, if you will. And Hoodie also provides the other part, right, which is a comprehensive self-managing kind of table management. It self-optimizes all these tables, which is, I think, a very unique capability that Hoodie has. And it's key for warehousing and getting really good performance on the analytics tables, right? So yeah, same thing, right? I've also seen our competition try and minimize this to performance in a lot of cases. But actually think about it. All you do on the Lakehouse, the query engines query the data, right? The remaining, all you do is write jobs and pipelines and do management. What else is there, right? So Hoodie makes all of those run faster, take less compute, and all of your spend is on these jobs and management pipelines. So yeah, this should be a key consideration for people out there. That's like how we view it.
Okay, yeah. Yeah, it's a very fair point because the literacy around building an incremental pipeline is kind of emerging right now to handle this one. Another common feedback I'm getting for the Hoodie side of it is specs are a bit easier to read and understand. Jack Vanning got a little bit of a consistency model that he also pointed out. Hoodie is a little more study required to understand. And also like Hoodie has so many config knobs and steep learning curve. That's a very common thing people are pushed forward. How do you think of that?
Are we now saying that we should start designing complex data system based on what can be only easily understood? Look, Iceberg started very simple, right? I just did a control P on the spec page this morning. It's 123 pages long. As you evolve and get parity or more features, there's a lot more involved. For example, for us, we didn't have the luxury of slowly trickling MOR or incremental metafields. Going back to your question about the companies we were building this for, we weren't trying to build Hoodie and figure out how to start Onehouse on top of it or whatever, right? That's not what our consideration was. Our consideration was build this and make it run for companies who, the company that employed us, Uber, or the companies like that, right? So we needed most of this in point one, right? Point one, Hoodie had automatic file management, indexes, and incremental queries. Like it does feel like there's a lot going on in Hoodie, but what I would like to point out is we are slowly copying these features into other formats. It will get there, right? Because if you want those capabilities, you'll get there. And the Jack 580 blog, I think what he writes, the one point that I agree with is, just for the fact that Hoodie built like a managed table format, if you will, versus just a plain table format, doesn't mean it's wrong, right? It's more advanced and it does this learning curve for you. The second point on the knob specifically, I think some of this is fair and I take some of the blame for that. I'm from the database world, and most of these databases, actually, if you look at it, go look at AutoTune or services like that, you have hundreds of parameters. Like any useful database that does something like real production workloads have a lot of configs, right? This is also why we say Hudi is much more than a table format. It has a runtime, if you will, which can do the table management. You can control how you want to optimize the writes, what type of indexes you want to choose, right? It's almost like a distributed database. Think of Hudi as like RocksDB, when, like an embedded engine, when used along with something like Spark or Flink. That's the right way to think about Hudi. You actually cannot find a lot of videos of me talking about Hudi as a format. So we never thought of it that way. Valid point though, we put a lot of effort into this because for a data engineer out there who's not very familiar with databases, the baseline is Parquet files being written from a Spark job, right? We've done a lot of work around this. If you check out like point 14 or onwards, our quick start, we have one-to-one parity with how the experience is with something like Delta. Delta made it very easy to get started, get used, and all of that. We actually have one-to-one parity with those. If you want to customize keys, use an index, you can slowly introduce those advanced capabilities. We've done this change in the last 18 months. There is also a good set of users who like the flexibility and the knobs.
Yeah. It's interesting that you mentioned like a managed table format versus open table format. I started to feel the pattern where the open table format and the vendors are trying to do the managed version of that open table format. And that's where most of the vendor locking is happening. And I started a question after you're telling, like, is it like open table format is a good thing or a managed table format a good thing or not?
My view is open, no unmanaged being free, and just managed being proprietary is a bad thing for us, right? Hudi has had a high performance managed table format in open source for years. And the choice is the user's choice, right? So you can either take a simple table format and go for compatibility, or you don't want the management to be done. Onehouse can just do that as well if you want. But for us, we give our users options. You can either take Hudi, it has management in open source, you can use it yourself. And I can briefly talk about the kind of companies who are actually taking advantage of something like that. But at the same time, if you don't want to do, that's where we exist, right? As Onehouse, we can exist and help. So this is the impact that Hudi has had out for companies out there. We estimate about 23% of Fortune 100 using us directly, right? And all of them are getting managed table services for free when you write data. So we cannot manage that. We are around to help, but we want the world to have this option. If you just say open on the format and lock every service around that, we have not progressed as much as an industry, I feel. By any metric that you evaluate this project, I think it's been a smashing success story in the industry for the last 8 years. Thanks to the community for making this happen, I would say.
It's a tremendous 30 to 50 monthly active Hudi contributors. It's really impressive. Can you talk a little more about Hudi 1.0 features and what you're excited about?
Yeah, amazing. Happy to do that. For people who are watching, you can go to the short link or scan the QR code for the release blog, which goes into all these features in more detail. But in a nutshell, we've really done, I think, justice as a community to that big version bump that we've done here. So the changes that we've done, to just summarize the highlights, are very foundational changes, right? So one, around the stable form, the storage format itself, we've reimagined the Hudi timeline, which stores all the actions as an LSM tree. You can store up to, for example, 10 million commits, which is you can do 30-second commits for up to 10 years on a table, and we can store it and retrieve it very quickly. So this is a common bottleneck that we see with Hudi, like even other table formats where we focus on the data scale, but you have to expire snapshots more frequently, and you have to do that kind of metadata management on the metadata itself, and people want more history, right? Number two, we've added something very unique, partial update encoding. If columns change, we only encode the changing columns and can intelligently do vectorized merges of the same thing. So it results in actually orders of magnitude bytes, fewer bytes written when you're doing like SQL merge operations and update operations or even like partial updates. And as a result, you're scanning like fewer amount of data from cloud storage. So your queries are also faster. So this is like a very fundamental change. It also helps us add blob support and all of that later on, right? If you imagine that if you have a table with a large blob, you can't be doing a copy and write or doing full rewrites of the RFC for wide column support for ML feature stores. There are plenty of use cases where this is going to be critical. And we have just like a faster merge and read, right? Which has like lower write amplification. The second aspect is indexes. So we heard about indexes on databases, right? And we've had indexes on the writer side for a while. So we generalized them on both like writer and reader. And we've brought secondary indexes now and integrated with Spark SQL. There's a near standard SQL syntax for create drop index, and you can create multiple types of index. And something like a 10 TB TPCDS web sales table, we see 95% improvement in those queries when you use an index, especially for high cardinality columns. This is the capability that Lakehouses don't have. And this is also a good example of the kind of innovation the community is doing, right? And the other thing I would call out is we are trying to move the Lakehouse away from partitioning more towards indexes. So if you think about it, a partition is basically a very coarse index on the data. We've introduced like Postgres style expression indexes. So you can create a index on an expression of a column. So essentially you can say like date of TS and then create date partition tables instead of actually partitioning the thing. So this is logical partitioning, if you will. Then Bloom filter indexes. So generally like heavy focus on indexes, and we can build these indexes going back time to concurrency control now. We can build these indexes without taking down the writer, which is a key thing. You can't put the table offline, build an index and bring it online. It all has to happen very seamlessly. We build all that machinery, and a good chunk of that is powered by this new thing called non-blocking concurrency control. So we've standardized the notion of time around true time semantics from Spanner, which is good enough for low latency OLTP stores. It's great for Lakehouses. This unlocks things like streaming joins. Right now, you can't have two Flink jobs update the same record in a Lakehouse table because optimistic concurrency control, one will fail, one will succeed. We've removed that. And even for batch jobs, this means you can do efficient GDPR updates. Typically, we've seen online writes to a table. You do a job to delete the thing. Some part of the delete overlaps with the write, and then the one of them fail, right? So this results in a lot of cluster compute usage, wastage, and all of those things. This really is a game-changing thing where you can actually finish these things and the system can order them consistently based on the event time or commit time ordering. So it can give you both either relational semantics. You're like, I want like data to be consumed in the order it is committed, or we can merge record at the record level. We can merge based on a event time feed, right? This is like a streaming primitive where you can have late data coming in 2 days later, but the system is intelligent enough to compare them based on an event time field and suppress the late arriving data. Or essentially, we've up-leveled the pre-combined functionality that Hudi has already, which is, to your point earlier, this is one of the things that people are like, but it was harder for people to put it in context and compare it to other table formats, right? We've improved and announced a lot of features on the incremental processing side. We've consistently been contributing industry first features when it comes to the Lakehouse. When you measure by which project has originated the most innovative for the kind of like features, right? And now I think this sets that bar high again. I think you will MOR and incremental writes, writer-side indexes. All these are things that we've had before other open source projects. And this is why I say we like to invest in this kind of open source software stack that can, with these capabilities, not just the table format layer. And we've grown really well during this period alongside Iceberg.
Yeah, totally. A lot of the features are I really like, and some of the things are real world problems. If, example, the secondary index support after a table may be partitioned by a certain, let's say, date time, and there is a account or a company ID is there, and some clients wanted to query by company ID, somebody wanted to query by timestamp. It is always a very confusion, and we often produce two different materialization of the same version of the table in order to optimize client consumption. I believe those cases where secondary index might be great, and then logical partitioning, like skewed partition, is always a bigger case. Logical partitioning or expression indexing is a perfect choice for you to efficiently index those things. And concurrency control and event time processing. I'm glad this is a first class citizen for in a table in a Lakehouse. I often face the problem where this is not being supported, and then we hit cross. What should we really do with that? And
Yeah.
you don't push the complexity back to the upstream. For example, if you don't provide a non-blocking concurrency right approach, then somehow you have to buffer it, make sure that only one record getting written serially. So it's removing a lot of complication from a system design perspective from an upstream, make your developer life a lot easier.
You need a Kafka cluster in between. A lot of people just introduce a Kafka cluster in between. The Kafka cluster basically gives you that serializable log and just make this like single writer, right? That's what most people do.
Yeah, and it also create, like when you introduce a Kafka, then you create head of the line blocking and all sort of other nuances associated with that one, makes an architecture more and more complicated. So I'm excited about these features and curious to talk more to the community to understand what are the use cases they're solving that, right?
Yeah.
Switching a little bit on back to the ecosystem of a model. If you notice, there is a common perception that Iceberg has won. Like 2024, if you see like last 3 months, I've seen like increased number of posts coming in, like as Iceberg is in. Even anti-Paul recently got out in this 2024 database review quote, Iceberg is the standard, sorry, Hudi. What do you think of this industry perception? What is the response to it?
Yeah. First of all, I really like Andy. Obviously, a lot of people do. I'm not unique in that thing. And then, but I think Andy was commenting about the Databricks acquisition and the follow on with S3 tables, if I remember right. First of all, apologies accepted, since I think it did not add such a lot of context. In fact, his apology could apply to Delta Lake as well. Look, so there has not been this level of drama in the space for a while. This is around a few megabytes of manifest files. Last time we had this was 2010. I'm old enough to have lived through that, when Hadoop could do anything from laundry to cooking, making meals and whatnot. So this is generally the hype cycle in the market. To many looking from the outside, this is a very common way of looking at what's unfolding. Usually I provide a technical explanation for this and talk like how we've been talking about this. But I want to actually, this is drama has unfolded over 3 years and we have very short memory. So I'm just going to try and first put these events into a timeline and share my take on what actually happened. Any war has a timeline. This is the table format, war timeline, if you will.
You became a
historian now. Yeah, I think. But look, this whole thing started with late 2021. Databricks and Snowflake went to all the benchmark wars. Then there was this Lakehouses warehouse push, right? Which 30-year-old technology are you using? I think most people remember those ads, right? Then summer, essentially this pushes Snowflake at that point. And I think even as of at least the last year, most of the data sits in a proprietary format, right? So Snowflake had support for Iceberg. And then initially, it's not on par with their performance, right? This is from Snowflake's blog. And then putting the native and the external format. So it sells a reaction to what Databricks was doing at that time. And the next 24 months, there's a lot of continued Iceberg messaging from Snowflake, a lot more vendors jumped in to hit two targets with one arrow. If Snowflake's going to offload data into an open table format, I want my engine to be prepared for it, right? Snowflake is the incumbent cloud data warehouse. So that's the first target. Second, you counter Databricks in Delta Lake, right? So this is like a perfect situation so you got a lot of people jumping in to that thing, right? And by the way, I'm not discrediting. Iceberg has its own features, users. They did a good job with the format standardization or the high replacement they did. So that's not what I'm trying to say. But this is basically what propelled the industry. I think this contributed to this mostly. You can go look at Google Trends and I think this will correlate. By summer 2024, for whatever reason, Snowflake didn't GA this for 2 years. So there's 18, 17 mentions of Iceberg in the Snowflake earnings report. There's a lot of rumors about Snowflake buying the Iceberg right now, right? Databricks acquires the Iceberg startup and announces that we want to converge the formats. Delta Lake is format agnostic. As of today morning, Delta homepage has Hudi, Iceberg, like all of the compatibility with both Hudi and Iceberg. So the world is very different when you're on the one of these 3 open source projects building on the lake, right? This has created this perception that since Databricks bought the competition, Iceberg has won. My take is very simple. What does this have to do with Hudi? Most of this does not actually have much to do with Hudi as a project or a community. During this time frame, we've grown pretty well alongside Iceberg and all this happenings in the industry. I think it's not an accident. We've grown because of these technical differentiators and the focus we've had on solving these hard problems. We are the only project that can actually asynchronously compact while without blocking writers, right? This is like super critical for incremental writers. So that is what holds water for the project. right? And in my opinion, all you need to think about when picking a project is two things. Is it right for my use case? And does it have staying power, right? We've talked about all the use cases that's like a good fit for, in my opinion. There are use cases that Iceberg or Delta Lake are probably like a better fit as well. But longevity, we have staying power, right? We've been around for 8 years. We powered a good chunk of Fortune 100. The community is the community. Onehouse is not equal to Hudi. But a lot of people look at it that way. But for that matter, even we're well funded, we're innovating, right? And as Onehouse, we support all engines, all catalogs, all formats. We will support what the market wants, but we'll keep continuing to innovate on the Lakehouse space as well. I have a balanced view of this, and I encourage more people to deeply consider what's going on, not even for the sake of Hudi or versus Iceberg or whatever. We were there in the Hadoop wars, in the same situation where Hadoop was sold to the moon and back as the panacea for every problem. It's really not how computer science works. So that's my simple take.
Okay. Just for the housekeeping for the audience, if you have any questions, feel free to ask in the comment section or in the Q&A section. Thanks for the answer, like a kind of detailed view and the historical take on it. I love histories. The vendor games are very interesting. If I'm an executive, the notion of having this open standard for me is very appealing, because earlier I used to have proprietary systems like Snowflake or any other ecosystem. Yeah. Suddenly an executive hearing that there's open table format, you can pick and choose your tools, and the cost and everything is in your control. That's very appealing from an architectural standpoint. So what is the technical take on that? The whole standardization is the right way to see through this one. What is your advice to a data architect or an executive thinking from a deep technical perspective? What should my data platform look like?
I think it's a great question. I don't like to use the word standard very casually, right? But Hudi and Iceberg are like standards for different things, right? So standard for what really matters. You can pick a standard for the new Hive. I want a new Hive table that definitely has its purposes. You can have multiple engines on top of that same table, but I still feel like there's a lot of work to be done in educating the market broadly on how to use the right engine for the right workload on top of that same table. So for any architect, my 2 cents is to consider what standardization buys you and what you lose along with that. Specifically to your previous question, there's a lot of, you pick the standard and everything's done kind of narrative going on. And I feel that's like an optical illusion, right? If you think hard, there won't be a standard format for data in general, right? Even now, all the warehouses have their own proprietary table formats, which store vast majority of their data, right? So that doesn't mean they're losing or people are going to stop using them, right? They all have their purpose. All the open source analytics, like the Lakehouses, like the Trino, the Pino, the Druids, and all of that, like they all have their own custom formats for their use cases. So I think we just need to balance the standardization discussion with the use cases you want to support and whether it can satisfy those use cases in a meaningful time. But right now, there's a lot of, the Delta Lake Hudi should converge while everybody has their own proprietary table formats, which is like a very odd thing, which I see. And we just can't do that. We have like responsibility for open source users. It's not a switch that we can flip and be like, we fixed all these feature gaps on this new standard now, right? It's a process. It will take over time. And you still, like as an architect, you still need to support those use cases for your organization during that time. If it takes 3 years to fully converge, what are we going to do for CDC workloads until then? Mm-hmm. That's the key consideration, right? So carefully consider what you gain and lose with the standards.
Mm-hmm. I have a very hard question for you now. Do you consider Iceberg as a friendly or a worthy competitor? And then what's so wrong having a standard table format? Just address that particular question right now. And the second recently, I kept trying to bundle a lot of questions into one to the interest of time. My follow-up question with that is Databricks recently bought, and now Delta Lake and Iceberg kind of one in one. There's a lot of internet meme on Iceberg shrinking. Do you think Iceberg is a worthy competitor and built in Delta Lake? Do you think Delta Lake will die or Iceberg will take over as a standard across all the table formats?
I'm going to use this visual aid to put the layers in perspective. I think the table format layer is like checkers. Right. So it's like really the analogies, like one is complex, takes more time to master and all of that. The other is like a simple thing, easy to learn, get going. So I actually think Iceberg is a friend in some ways because Iceberg support is good for Hudi. Without Iceberg support, for example, there is no way for us to easily marry Hudi writing and Snowflake queries, which is a really powerful combination, right? We can land data quickly into a Lakehouse. Snowflake has a great SQL engine, easy to use product that can sit on top and query. It's done a lot of good for us in terms of unlocking the reach of Hudi data into many engines. So BigQuery has native read support for Hudi. Redshift has native read support, but something like Snowflake where there is no native read support, I think it's been like specifically very helpful. And obviously there's competition and friction. I think most of it honestly comes from the way that Iceberg is standard proclaimed by non-Databricks vendors unilaterally. The problem that Databricks now solved, I think, with the acquisition, they have a seat at the standardization committee, if you will. So to me, that's what I'm saying, right? The real standard should be co-designed by the three communities who contributed to the Lakehouse technology. So which is the Iceberg Hudi Delta Lake community. And as the common perception goes, that talent is now concentrated in two companies out there now, which is maybe Onehouse and Databricks, right? So I think we'll work more closely to converge around the same model. These are different layers of functionality. This picture, I feel like the table format is like a more basic layer that you need to share metadata stats and lay out all these things. If you look at both Hudi and Delta, they talk about themselves as a storage framework of some sort, right? We either call it an incremental processing framework, data lake platform. There's a lot of emphasis on the software stack on top. It's not just about the format standardization. So I think the way to go forward from here is have interoperability from the data lakehouse framework layer into the table format layer. And that will help bring some peace to the ecosystem. The other part that I'm looking forward to chatting with you more on is what is actually happening right now in the name of open table formats is actually a lot of vendor compute lock-in on that. So this is again like another, we should have the end-to-end software stack. But yeah, on Delta versus Iceberg, that was your last question. We see anecdotally, of course, like a lot of people at Readment who are like wanting to now go evaluate Iceberg because of the same fact that Databricks now this way. So does that mean Delta is bad? I should be on Iceberg, like, oh, yeah, right? Same, right? Same. I have the same feedback for them. Carefully evaluate what your use case is, whether you will get far, does the standardization, what does it buy you and all that. So yeah, ironic that I'm the voice of support for Delta. I should be like, we competed, but we have healthy respect for them. Look at your workload, evaluate if the standardization buys you something or not. I actually think Iceberg V3 is more Delta than Delta being Iceberg. I really hope we don't end up with a format war within Iceberg with V2 versus V3, where Snowflake says, oh, I support V2. And then we say, oh, no, V3. So this would be like a kind of tragic outcome if that happens. But I hope it doesn't go to that.
I'm sure many people will quote you now. They mentioned Iceberg will become Delta. It's a very interesting quote.
That's true, right? If you look at the V3 spec, it has the same Spark variant support as Delta. It has the deletion vector support. V2 had like delete files. So it just feels like V3 is Delta. Iceberg V3 is Delta, not the other way around. And I don't know if Databricks has officially a stated position on like Delta going away. This is what I want to tell everybody. There is two sides of this coin from the three communities who built this technology 7-8 years. And there's the other perspective where all of the warehouses and the clouds and they're adopting the new technology now and have their stated positions based on some competitive landscape, right? I think it'll all converge in some way.
Yeah. Yeah, vendor talks is always interesting. You spend a lot of time in cultivating open source community and then building a lot of open source softwares and now running a company on top of open source software. 24 is a lot of interesting happening in the industry around data, this whole Lakehouse format and industry. What do you wish collectively 25, 2026 and beyond from the data community, the users and the vendors and the builders? What we have done good and what we can do better?
Yeah, I think we do really well. I'm super happy to see how vibrant the open source community, the ecosystem, the reach of open source technologies right now has been like, that's its peak, in my opinion, considering you building a data project like 10 years ago and now in open source, it's like your market's much bigger. There are a lot more people who care about open source data, which is like super great. It's like mainstream. Many have recognized this to be the way to build open data. And if you look at the DB rankings, the open source software actually crossed over the commercial software last year. So it's great science. That's all awesome. We have a lot of choice, and the results say like same thing, right? There's a lot of responsibility here. So I wish like we don't have so much recency bias towards evaluating things. It's a lot of choices. It's hard to evaluate things but if you don't do those choices really well, you could actually cost your team, your company a lot of money, or you can lose out projects, competitive edge, right? So we also need to not distrust evaluations all the time, and be like learn to do these evaluations in a meaningful way. It's like super, super hard, right? From an OSS community perspective, especially around table format and stuff, I really wish we are like more collaborative across the aisle, and like actually even frequently kind of credit each other for like features that are borrowed and kind of things like that. It's otherwise the same thing gets reinvented without a lot of like collaboration. And then we are just like redoing the same thing across 3-4 years. Like that's so like even this conversation, like look at the amount of time I'm spending on indexes and all of these things versus like format standardization, right?
Mhm.
So I think we are shying away from talking about the harder problems and drafting along the common narrative, if you will. So I think I wish we get deeper and deeper, and that's just not for the users. It's also for people like me to make it easier for these kinds of things. Right?
Thank you so much. I have tons of other questions, but we have some interesting question from the audience. I want to go through that particular part of it. The question from LinkedIn, when are we bringing right capabilities to Trino connector for Hudi?
From our standpoint, I think when I say that the Hudi community, it's a prioritization, right? Vast majority of the writes on Hudi happen via Spark and Flink. We support like queries via tree now. And I think the 1.x release line, we're going to release what we are going to call a storage engine API. And which should be something that like the community and us, we can embed into Trino and make that writing faster. So the main thing here is look at these capabilities like indexing, right? So Hudi Write DAG does need a good level of flexibility to go update the index and update the table, keep them consistent, like all of that things. We need to have that conversation collectively with the Trino community once we have the storage engine APIs. For now, we still see vast majority of users are like querying with Trino, but writing their pipelines in Spark or Flink. That's
my number one criticism on the current Lakehouse. It's predominantly having a high dependency on Flink and Spark, and I don't have the freedom to write myself. Like why I should have some frameworks to do that, and then different frameworks supporting a different cadence. And that hindered this whole adoption curve, essentially.
I want to unpack that a little bit. Is the problem that you have to use multiple engines to do a simple thing like writing a table and then querying it? Or you feel like Spark is the problem or the packaging is the problem? Because I do have a position on this, but I like to understand, what do you think is the actual gap?
It is an operational headache that is adding, right? Let's say I wanted to write to Kafka, to Hudi, or any other Lakehouse format, then I was forced to choose one of the Spark or Flink or any other support, like where I wanted to have a very simplistic consumer should do it.
Yeah.
And that won't support a Medallion reader. I had to run some complex pipeline out a streaming system that I don't need to run.
We do support a Java client, and I think the other projects too. There's the RS, there is like Iceberg and all of those. So that ecosystem is developing as you speak. But and you're right. I think at least for some of these use cases, I think you like the simplicity rather than learning like a large, heavy tool, data processing tool like Spark or Flink. So that's there. The other aspect I actually see more commonly within this neck of the wood where people are like actually doing data processing is the packaging. So when we look at it, I feel like we are in slow motion building a database. This is what I realized. There's a seminal paper on database architecture of a database system. If you are interested in this 80-page paper, please go read it. Like it'll change your perspective on what databases are. And I just mapped all these components. But if you look at it, we're lacking a full open software stack. It's a library. You take it, use different engines to read, right? So a lot of people want that flexibility, right? So the biggest thing that we talk about table formats is I can write from Snowflake, I can read from Databricks, I can read from people want that multi-engine pluggability, portability, but that cannot be the only way, right? There should be a much easier way to get started in open source on a data lakehouse. That's a gap I see. And this should abstract away the formats in any database. They hide all these details, right? Nobody talks about them at this level. There's caching, there's table services, and the use case you talked about comes in the data loading. This is the replication and loading. If we package it really well as installable cluster software, this can solve some of the problem. And even if you do it on Spark, as long as it's hidden from you and it doesn't spew Java stack traces at you, maybe that's good enough for you to get started. There is no easy button. You can't do Docker install and do something on the Lakehouse today. That's the gap. It's a great point.
There was a question about your 2025 prediction, but what would you like to see in Lakehouse development this year? This is exactly what I wanted from the Lakehouse, because these are the common problems in any architectural things, like what database is supposed to give you out of the box. Since it is not giving, it is pushing the complexity upstream. And we talked about introducing Kafka, and then you have a Flink, which otherwise you don't need to maintain that. And it's making the architecture much more complicated. I wish the diagram, the architecture view that you shown, that kind of coming reality in 20. Next question is, do you envision using and adding variant type in Hudi in the future?
Yeah, I think not just variant, I think we plan to generally support for blobs in Hudi. Like I mentioned, a lot of the storage format changes are actually foundational work for that. So I think we'll be steadily adding all these different data type supports this year. I think our approach is to be more convergent with the combined Iceberg Delta as we do it on variant and stuff, right? With Spark and all of that to minimize friction for these things. Right. We are going to have areas where we innovate ahead. You'll see us doing our own thing. That's generally how we plan to do it. But this is going to be a major focus this year. Blobs in general, not just this. Yeah, I'm really excited for that. We have code sitting in the repository for indexes. You can do text search indexes, bitmap indexes. Like we can do like a lot of different things and add a lot of different data types and generalize this. Hopefully we can package it so you can get started quickly.
Yeah. A lot reminds me of Vinoth format does support a very flexible way. You can pick and choose what index you want on each column. I think that's very powerful. I'm glad the similar concepts can permeate to Hudi side of it. Variant type in particular, I think most of the data, even though people are saying structured, like many are semi-structured information. Yeah. I think variant type I've seen like predominantly used in many enterprises on top of their side. And moving on to my favorite question, does Amazon have any plan to update EMR to the latest version of Hudi? My additional question is, do you think S3 table discussed a lot? Do you think S3 table will support Hudi also? Both combined. Okay. All right. First one, I think we're already working on it. I think with the EMR team, we actually meet every week. We've been meeting every week. Like essentially there's like a sync meeting that we have. And I think they're working on Spark. There's a PR for Spark 4 support already from them. So I think it'll be there. S3 tables, I think I have so many reactions to that announcement. Right. I don't know if S3 tables will have Hudi or not. I think they've left the format more as an option. So maybe they'll support everything over time. Overall, S3 tables itself, I have a lot of reservations and concerns about based on how it's landed in its current form. I really wish it doesn't become a lock-in point at the storage level. This will be like very crippling, even to large companies like Snowflake or Databricks. Users should be able to pick who manages those tables on top of S3. So you can use S3 tables if that's better, or buy it from some Iceberg vendor or Snowflake if needed. But I don't know how far we are from that. Well, an interesting question from like, can you talk a bit more on metadata table and how it is going to be evolved? Most of the new indexing features are tied to it. Would like to learn more on this. Yeah, it's a deep question. Thanks for that. From an evolution standpoint, the biggest change that we are going to probably do on 1.1 is change the updation of metadata table in a streaming fashion. So from the writer, I think, and switch the metadata table to like non-blocking concurrency control as well as a default. So I don't know if that like quite answers what you're looking for. But all in all, as it stands right now, all of these indexes are built on top of the metadata table. Every index is a partition in the metadata table. It's like very easy for you to drop and recreate indexes. And so it's going to continue to be like a large part of the indexing story and metadata in general. We are thinking about specifically pulling files partition out into its own design. So some of this design is tied to structured data, right? When we did that, the format originally. So as we move towards unstructured data, we should probably decouple the file listing from everything else.
We probably do some changes around. But by and large, it's going to become much more performant, very streaming friendly, so that you can update the indexes from Flink as well, for example, which is a limitation today. Indexes only work on Spark, right? So we're going to be steadily working on making those work. To the Trino question earlier, I hope that is going to help us also solve some of those, bring the same capabilities to other engines like Trino or Presto for that matter.
Yeah, we're almost out of the time. I'm just taking a last question from the audience. WCM source implementation is available for MySQL and Postgres. What's the plan for other databases like MongoDB?
I think if we see a Jira around it, we'll probably jump on it. So please file a Jira. I think there's nothing stopping us from doing that, except that we need user feedback on things like this.
Mm-hmm. Yeah, I have one other interesting question. So I'll just hold off for another question from the audience. A simple issue. Let's say I have a streaming pipeline running in Spark, which is writing to a Hudi table. Now I wanted to insert data into this table by selecting some columns from another table. Or let's say I want to back populate data into this table from a historical table. I had to create another Spark Flink pipeline for this rather than firing a simple Trino SQL query to insert into the Hudi tables. Another point is table maintenance operation like compaction, clustering, cleaning, UDB, schedule as a SQL queries to automate via Trino, plus some workflow tools like Airflow, Daxter.
Yeah, so I think all of what is talked about in this question are doable just from Spark. If you replace Spark with Trino, I think you have no issues here. So the issue here is fundamentally Trino, right? This generally ties back to Trino Hudi support, right? And it's also the one area where I think there's a lot more support on Iceberg than Hudi. This is a question for the Trino maintainers and everybody as well, right? So we should fix the Trino writing. I agree with you. I don't agree that it's easy to schedule maintenance as SQL queries when you talk about automation. I actually think the Hudi, the strategies and all of that we ship that do a far better job at automating that, right? Like Dragster and all these workflows, we can periodically call clustering, but the strategies you have in Hudi can figure out what's really changed in the table in the last 10 commits and then trigger clustering. So for us, we would like an experience like that for Trino, but I think it's a matter of who does the work. If you are interested, please ping me on Slack. We are happy to guide you and work with you to make this happen. Otherwise, you're already running a Spark job. So why are you using Trino? You can just use Spark job.
Thank you so much, Hiraz, for all the detailed answer and thought-provoking insights. Thank you, everyone, for joining us today.
Wish you all a happy new year and hope you get the success that you want this year. See you all in the community. Bye.